Alright, what's going on, guys? Before we start the video, there's a couple of terms that I want to differentiate and explain what they mean. In the video, I've used them interchangeably, but they have very specific meanings or are used in specific instances in regular expressions. So you guys should have no problem following the video, but I just wanted to sort of clarify what each of these terms mean so that it should hopefully aid you in understanding the video a little more. So we have two different words. One is called capture and the other one is consume. So capture seems to be only used in relation to groups. So when a group actually outputs something, it's considered a capture group. So we have non-capturing groups and capture groups. So a non-capture group will make a match, but it won't actually output that match, as opposed to a regular group. A regular group is considered a capturing group and always outputs whatever match it makes. Okay, so that's capture. So capture is actually only used in relation with groups. Now, consuming. So this is another word that I sort of use interchangeably with capture, but a regular expression, what it does is it consumes characters. So if we have something like, say, just quickly, something like W, \W plus. So this is looking for all alphanumeric characters. So what happens is the cursor moves from left to right. Once it hits this empty space, it knows it can't consume this, so it goes back and all of this gets consumed. So when we talk about consume, it's essentially the pattern going through the string and trying to make a match. And everything that it sort of matches gets consumed and the cursor moves to another area. So in this case, all of this gets consumed and the cursor has moved. So the cursor is here now. So the regular expression has consumed this entire pattern, this entire word of the string, and the cursor is now here. So there's no match here, so what the regular expression will do is it'll go to the next character. There's no match, and then it'll go to the next character. Okay, there's a match, or what seems to be a match, and then it'll check how much it's actually matching, and it matches all of this. So what happens here now, the regular expression will consume all of this. So this all matches. So anything that matches gets consumed, and the cursor moves here now. Yeah, so anything that's consumed is considered a match to the regular expression pattern, and what that does is it moves the cursor. So that's the main thing I want you guys to take away from this, is that anything that consumes essentially moves the cursor. In this case, this pattern will consume this entire portion of the string and the cursor will go here. So consumption, once again, is just the pattern making a match and having the cursor moved to the end of the match. So that's so that's basically what I'm meaning by what's meant by consumption in regular expressions, and hopefully that gives you enough intuition to really understand the video, because lookarounds don't consume. What's going on, guys? Welcome to Python Regular Expressions Made Easy Part 14. In this video we will be discussing lookarounds. Lookarounds is a very powerful functionality of regular expressions, but it's also very complicated. It can get very complicated. So hopefully it's not too bad in this video. Okay, so let's just dive right into it. So what lookarounds allow us to do is they allow us to confirm some sort of sub-pattern or mini-pattern that is ahead or behind our main pattern. Now you guys might be thinking this seems very similar to non-capturing groups, which also work in a very similar way, but there's some very key differences, and hopefully I'll be able to showcase the key differences very clearly. So lookarounds allow us to find a sub-pattern either ahead or behind our main pattern. And the first thing we were going to do is look at the types of lookarounds. So there's 4 types of lookarounds. There's a positive lookaround, which is represented by a question mark followed by an equal sign. Now, a lot of these symbols are very similar, so you're really gonna have to pay attention. You don't have to memorize, but just be aware. Sometimes when you're looking at regular expressions, you might not be able to tell the difference. So I want you guys to pay special attention to all of the syntax so you guys won't make any mistakes in the future. So a positive look ahead is a question mark followed by an equal sign. Now we also have something called negative look aheads, which is we want to confirm that this group is actually not following our main pattern. So earlier I had said we're looking for sub patterns ahead or behind. We can also look for sub patterns that are not. We want to confirm that this sub pattern is not ahead of our pattern or behind our pattern. So a negative look behind is a question mark followed by an exclamation point. So the one thing you want to realize is that a equal sign means positive and an exclamation point means negative. So those are the two sort of symbols representing positive and negative. Now if you want to do look behinds, all you do is you add this less than sign. Yes, this less than sign in between the two. All you do is take the positive and in between both you add a less than sign. So these are the four types of lookarounds. Now you got to be careful because there's a lot of similar syntax that in regular expressions. So we have non-capturing groups, which is a question mark followed by a colon. Then we have naming groups, which is a question mark followed by P. So question marks are used extensively in regular expressions, and you really want to be careful with all this similar syntax, especially since my examples are going to be using a lot of this syntax. So yeah. Alright, so yeah, so four types of lookarounds: positive, negative, ahead, and positive, negative, behind. Alright, so let's just get into an example. Some of the examples I found through the net, and some of them I just sort of tweaked around and try to make examples for this video. So we have an example here. It's in the below string, we're looking to consume the second column value. So this is the second column value, 111, XXX, only if the first column starts with ABC and the last column has a value active. So we need to have fit two different criteria. The first one is ABC1. ABC. So the first column has to have the word ABC within it, and the last column has to have the word active. So here we have active, and this one's inactive. So what we're trying to do is we're trying to pull out the second column only if the first column has the word ABC within it, and the last column is active. So if we look at the first and last row, the first and last columns, we see that only this row and this row, the first and third row, satisfy our condition, our criteria. So we should be outputting this 1111 and XXXXX. Okay, so now let's take a look at how we can do this using lookarounds. So let me just run this string first. Okay. So we have this pattern already compiled. So let's break it down. The first thing we're looking for is ABC, which is pretty simple, followed by an alphanumeric character. So it could be 1, 2, 3. It can be another letter. Doesn't matter. So our pattern is ABC followed by some sort of character letter, because in this case all the ABCs are followed by some sort of character or letter. Then it's followed by a space. Then it's followed by a bunch of non-space characters, which remember we're capturing because of this group. So this is one of the outputs we're going to get. Then it's followed by a space. So let's just take a look at this again. So ABC followed by an alphanumeric character. So ABC followed by alphanumeric character, a bunch of space, and then we stop here. Then a bunch of non-space characters, once again a bunch of space characters, followed by a bunch of non-space characters, followed by a bunch of space characters, and then followed by, this is where we use our positive look ahead. So essentially what this is doing is it's it's looking for the word active, but it's not actually capturing it. This is our pattern, and then it sort of checks to make sure that the word active is there. So it's actually not capturing us, and this is the only group where we're capturing. So let's just run this first. I'm going to run this. Oh, I have to actually import RE. Let me just do that here. Import RE. Okay. So I import RE, and let me just actually restart and clear output. Restart and clear all outputs, and we'll sort of start this over. Okay, so let me just run this. Okay, so we have our string. I'll run this. I'll run the pattern now, which we just discussed. And now we have re.findAll. So this is of course going to pull out these two. Because when we use re.findAll, it only pulls out captured groups, if there are any captured groups. But yeah, so just so you guys understand that this is not being captured, let's actually change the pattern around. Let's keep the pattern, but let's just use re.search. So we'll use re.search, pattern, and string. And let me just run this. So here's where I wanted to show you guys exactly what I mean by it doesn't capture. So as you can see, when we use re.search, it pulls out the entire pattern. It doesn't matter if a group is captured or not, because it has actually another method to access the group. So when we use re.search, what happens is it pulls out the entire pattern. So now we're going to see something funny in this pattern. So even though we have this portion here, right? Question mark equals active. So this positive look ahead, it's actually not being captured. That's a key point I want to demonstrate, is that it's not being captured. So if you look at re.match object, it matches all of this and it matches this, but then, and the empty string, but it does not match this active, inactive, or active. So this is actually a little confusing, but I'll have better examples to show you exactly what I mean. So remember, this is actually not being captured despite using re.search. So that's the key difference. This is something called zero width assertion, and I'll show you some examples showing you exactly what I mean. Okay, so we were able to pull out, with re.findAll, we were able to pull out these two. Of course, there's many different ways we can do this. I'm going to show you just another way of doing this, which is using a non-capturing group. So in this case, a non-capturing group works as well. So if you use a non-capturing group here, remember, the syntax is very similar. We have a question mark and a colon, question mark, and an equal sign. So you got to be very careful. This is actually a non-capturing group. This is a positive look ahead. Now if we use this pattern, this also works in this case with re.findAll. But now let's see what happens with re.search. re.search, pattern, and string. Okay, so if I run this, I'm sorry about all the noise outside. I'm actually in Florida, so there's we have that hurricane warning. So there's going to be a lot of traffic and noise at this point. So if you look at re.search, in this case we use non-capturing group. Despite using a non-capturing group, we still get the word active. Now this is the key difference that I want you guys to pay attention to. When you use non-capturing group, it's consuming the characters. And when a non-capturing group checks, it just doesn't capture to a group, but it actually, the cursor actually moves ahead. And with positive look ahead, the cursor is actually not moving. It checks and then it comes back. So everything before actually gets captured. And if you want to capture this, the rest of this part, you have to specifically write a regular expression for that portion as well. Where in this case, you have a non-capturing group, and this also consumes. Yeah, so re.findAll was able to, find the same patterns, because in this case, there's many different ways to get the answer we're looking for. And re.search, of course, pulls out the active word as well when we're using a non-capturing group. Okay, now here's the key difference that I actually have an example to showcase the key difference. So the difference between non-capture groups and lookarounds. All right, so say we have a string. So this AB, 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 ACB. Okay, so we want to pull out wherever A's are surrounded by B's. So in our case, there's two cases. Let me just make this bigger, just in case. Yeah, for those on the cell phones, yeah, this should help. Okay, so we have an A surrounded by B and B. So that's one case. And then we have another A surrounded by B and B. Now the key thing you want to realize here is that this B is overlapping within two patterns, or it's overlapping within our outputs. So we have BAB here, and then we have BAB here. Okay, so string equals AB, AB, AB. So we're trying to pull out two instances. Let me just reiterate, BAB here, and BAB here. So we're trying to pull out the two A's. Okay. So now we'll start off with non-capturing group, which is, remember, denoted by the question mark and a colon, question mark colon. And basically what we're doing is we have two non-capturing groups, the B and the B, and an A sandwiched in between. So essentially we're looking for an A sandwiched by two B's, but we don't want to capture the two B's. We're just trying to pull out the A. So in this case we want to pull out two A's, so I'll run the pattern, and now I'll use re.findAll to find all instances, and we get an empty string. That's because I haven't ran this string yet. Okay. Alright, so re.findAll, and we pull out only one instance of A. And that's because, once again, non-capturing groups consume characters. So in this case we have a B followed by an A followed by a B, and now this B is already consumed. So consumed in the sense that the cursor moves. So the cursor will move from B, it'll consume the B, consume the A, consume the B. It doesn't go back now after it's been consumed. So that's why with non-capture groups, you can't really deal with overlapping groups well. So now we have the same string, and now we're going to use a look behind and look ahead. Okay, so let's see. Let's just go back. Remember, positive look ahead and positive look behind. All we do is put this less than sign in between the question mark and the equal sign. And here we go. So I have a question mark, less than sign equal B. So this is a look behind. So we want to find an A, and then we want to make sure this is behind the A, and we want to make sure this is in front of the A. The only difference with this case, it does not consume any characters. So that's the key difference. So this will work perfectly. If I run this, we get two A's. So now let's go back to the string and see exactly what's happening. So we have an A here, right? Then we look for a B behind and a B in front. So this doesn't work. So we go to the next character, not an A, doesn't work. So now we go to the next character, an A. So what it does is now it checks if something's behind and checks if something's ahead, right? In this case, it's satisfied. But unlike the capturing groups, it doesn't move the cursor. It just checks and goes back to where it was. Non-capturing groups, what was happening was it checks for the B, and then the cursor actually moves. But in this case, the cursor is not moving. So it sort of checks and then comes back to where it was. So what happens is first we'll look for an A, right? So we find an A. Then we have to make sure it's preceded by a B. Is it preceded by a B? No. Okay. So what we do is the cursor, which starts off here, finds an A, then looks for if it's preceded by B. It's not, so we go to the next letter. So in this case, is this an A? No. So it goes to the next letter. Okay. Is this an A? We check. Okay, it's an A. That's good. Is it preceded by a B? It's preceded by a B. Okay, good. Now, is there a B ahead of it as well? There's a B ahead of it. Okay. So in this case, it satisfies, and now we look at the next character. So next we check out this B. This B doesn't satisfy the A followed preceded by B, so we skip that. Okay, next we have an A. So we check the A. Okay, this works. Now we check the B behind. This works. And now we check the B ahead of the A. This works. Okay, so our cursor is actually here. So what we'll do is we'll consume this A. And then we'll look at the next character, which is a B. This doesn't work. Okay, then we'll look at the next character, A. So it moves one by one because of the regular expression. The regular expression usually moves one by one, but these are not actually consuming any characters. So they don't move the cursor. The cursor will just check but come back to where it was. I don't know the exact order, if the A gets consumed first or if the B gets checked, but this is pretty much a very good overview of what's going on. So the look aheads and the look behinds are just used to assert, but they don't actually move the cursor. And this is known as zero width assertion. So we assert, but we put the cursor back. Now we check again. This doesn't satisfy, so we stay here. Then we check again. This works like that. Hopefully you guys can understand that. Capture the entire look around. Okay, so in this case, say we wanted to check if there's a B behind and there's a B in front, and also capture the entire group instead of just the A. So here we're just capturing the A's. What you can do is you can actually put parentheses around the portion you want to capture. So in this case, what I did is I made the entire thing look ahead. So what we're doing is we're looking ahead, and we're not actually capturing anything. So our entire regular expression is just this look ahead. So wherever we are, so say our cursor is here, So say our cursor is here, whatever's ahead of this cursor has to satisfy this condition, BAB. So if we start off here, this doesn't satisfy, this BAB satisfies, okay. So we'll capture this, then we'll move to the next one. This doesn't satisfy, so we'll move to the next one. This satisfies, then we'll move to the next one. This doesn't satisfy, so in that case, so that's how it works. And what we're doing is we're putting parentheses around the sort of the inner group. So we have the outer group, which is look ahead, and we're actually using a subgroup. So it's a subgroup of the entire look ahead pattern. So the look ahead group or pattern, and then we're subgrouping it with 2 parentheses. And this allows us to pull out the pattern that we're interested in. So in this case, BAB. So if I run this, run this, run this, as you can see, we get BAB. Okay, so, oops, not non-capturing group. This should be positive look ahead. Positive look ahead. Okay. All right, so here's another example of a positive look ahead. We import RE. This is our string, I love cherries, followed by a comma, and followed by a period. So let me just run this. And now what we're trying to do is we're trying to pull out all the fruits. So in this case, it's going to be a word followed by some sort of punctuation mark, word followed by punctuation mark, word followed by punctuation mark. Now in this case, I just want to show you that you can actually use many of the regular expression functionality along with the lookarounds. So in this case, we're using the OR symbol. We have a positive look ahead, and we're looking for a period or a comma. So this is the OR symbol, this is a period, and this is a comma, and this backslash is just negating this period. So we'll run this, RE.find all, and as you can see, we pull out cherries, apples, and strawberries. And we wanted to make sure we were looking for any word that is followed by a punctuation mark, whether it be a period or a comma. And of course, this is not capturing nor consuming. So the only part that gets captured is this. So we get cherries, apples, strawberries. Of course, we can use non-capture groups as well, and get the same as result. The only difference is, of course, this gets consumed. It doesn't get captured; it gets consumed. So the cursor will actually move ahead with non-capture groups, as opposed to lookarounds. It checks, but the cursor moves back. All right, so I think there's actually a lot more I want to cover, consecutives with lookaround fallacy and a couple of more examples, but this video is actually a little longer than I expected. So we'll end this video here, and I will continue everything in the next video. All right.